Hi everyone! Today we are going to be learning about equations. But before we start talking about equations, I want to do a quick review of something that you already know about, and it's algebraic expressions. So I want to start off with an example. Let's say I had something that looked like this. 3x to the power of 5 minus 4x to the power of 3. Let's do plus a half x squared minus 8. So this is a little bit more complicated than something we have worked with, but we're not going to do any calculations. I just want to show you a couple of things. This is called an expression, and there are different parts that we've talked about. So, for example, if I were to ask you how many terms does this expression have, you would count 1, 2, 3, 4. So we know this has 4 different terms. If I were to ask you what is the coefficient of the first term, you know that the coefficient is the number that is in front of the letter. So the coefficient for the first term would be the number 3. If I were to ask you what is the variable that the first 3 terms have, you would tell me that the variable is x, because you know that variables are basically the letters. Now in this example, I've only given you one variable, but you can have as many as there are. So you could have an xy, xyz, abc. Anytime there's a letter, that is called a variable. We've also learned that this is called the constant. A constant is when you have a number that is all by itself, so it doesn't have any letter attached to it. And we learned how to add like terms, subtract like terms, gather them up, and do different things like that. And so that is called an expression. Now today we are going to be moving on to the topic of equations. And the first thing I want to talk about is, how do you know what the difference is between an expression and equation? Well, an equation is something that has an equal sign in the middle of it. So you're going to notice in your expression there is no equal sign. In fact, when we were answering a question like this, we would put the equal sign all the way on the left-hand side. So there is an equal sign, but it's not in the middle of the expression. It's not in the middle of any of the terms. It's all the way on the left-hand side. In an equation, you are going to find that our equal sign is always going to be somewhere in the middle. So that's your first clue that something is an equation. Okay, so we're going to begin with our first example. Here we have an equation that says x minus 8 is equal to 11. And the first thing I like to do is I like to draw a line that goes down from my equal sign. And this line serves 2 functions. So first, I like to make sure all of my equal signs are going to line up in a nice straight line. And so drawing this line will give me a little bit of a template, so I don't make my equal signs go all over the place. Second of all, I like to consider this line to be like a magic wall. And basically, we're going to be throwing things from one side of the magic wall to the other, or we can throw them the other way around. So basically, things are going to be flying across this wall. And the concept you need to remember is that when something goes over the wall, the operation changes. So if you had a subtraction on one side, when you throw it over to the other side, it becomes addition. If you had an addition on one side, when you throw it over, it becomes subtraction. And our goal when we're doing questions like this is you want the letter to stay over here, and you want the numbers to be moved over here. Okay, so let's try this example. We have x minus 8 is equal to 11. So you're going to notice we have the letter here, which is perfect because that's where we want it to be. But this number does not belong. We want all of our numbers to be on the other side of the wall. Okay, so I'm going to start by writing the x over here because we want it to stay. We don't want the x to go anywhere. This 11 is also going to stay here because we want the numbers to stay on this side of the wall. But now, when we throw the negative 8 over to the other side, the opposite operation to subtraction is addition. So when I move it over here, it's going to become positive 8. And then all we need to do is just add these two numbers together. And our final answer is going to be x is equal to 19. Okay, so I've included another example for us to get some practice and get really good at this. So once again, I have an equal sign. That means this is an equation, and that equal sign is like a magical wall. We want our letter, which is x, to stay on this side, and we want to move all of our numbers over to this side. So now let's look at what we have. We have our letter, which stays here. We have a positive 6, which we definitely need to move over to this side. So in the next line, you're going to start off by writing x, which is your variable or your letter. You want your equal sign over here. This negative 9 is going to stay on this side of the wall because that's where it belongs. We want all of the numbers over here. And when I move the positive 6 over to the other side and you switch the operation, positive 6 is going to become negative 6. And then finally, we just have to add these numbers together. So x is going to be equal to, recall your integer rules. When you have the same sign, you add the numbers and keep the sign. So 9 plus 6 is 15, and the sign that both of them have is a negative, so it's going to be x is equal to negative 15. At this point, I want you to notice that I only have my equal signs down the magic wall. You're going to notice I'm not writing equal signs over here. In fact, that's not allowed. You're not allowed to have multiple equal signs. So you want to make sure all of your equal signs are just lined right down the magic wall. Okay, so here we have our third example. Once again, I have my equal sign. I'm going to draw my magic wall. This one looks a little bit different. So let's approach it in the same exact way. We want our letter, which is an x, to stay over here, and we want to move all of our numbers over to this side. But in this example, we have 4x. 4x is actually the same as 4 times x. So we don't often write the multiplication sign, but that's what you're thinking of it as. 4 times x is equal to 16. So we want to think of the opposite operation to multiplication, and that is division. So in order for us to get the x all by itself, we need to divide both sides by the number 4. And let's look at what happens. So we did 4x divided by 4 is equal to 16 divided by 4. We know that 4 divided by 4 is going to give us 1. And then the x just stays right beside it. So it's going to be 1x. And 16 divided by 4 gives us a 4. Now, often when you have something like this, a 1x, you don't need to write the 1 in front of it because we just assume that to be true. So our final answer is just going to be x is equal to 4. You have to be careful with this example, and you do have to try them yourself to see how it works for you. Our last example in this lesson is negative 6x is equal to 42. So I draw my magic wall, and I want my letter to stay on this side, and I want my numbers to stay on this side. And I want you to think of this as negative 6 times x is equal to 42. And the opposite operation to multiplication is division. So in order for us to get rid of that negative 6, we have to divide both sides by negative 6. And I forgot to mention in the other side, it's only in this example for multiplication and division that whatever you do on one side, you have to do to the other side. So if I'm dividing the left side by negative 6, I also have to divide the right side by negative 6. Negative 6 divided by negative 6 is 1. And then we attach the x over there. 42 divided by negative 6 is negative 7. And we don't need to write the 1 in front of the x, so my final answer will just be x is equal to negative 7.